Quantum Foam, Episode 31, College Physics.
Physics. Physics is at the foundation of all the mathematical principles that guide the heavens. You have to understand physics.
More than likely that's not going to happen, but
Forces which govern the universe. Physics.
All right. It appears that we have been able to acquire new information which will allow us to continue to transmit information from us to you.
Indeed it has.
We have more information to give out.
Need one must even ask?
We are approaching another decimal of the show here. We got 30 under the belt, and we are on to another decimal, which just means 10 shows. They're all 1.5 hour, and they start out easy and get a little more difficult towards the end, and each 10, there is generally a new character. But I believe what we are going to do is stick with the same 3 characters for the next 70 episodes. So the first 100 episodes will only have 3 imaginary characters and an additional real character, or really imaginary, or an imaginarily real character, however you put it. So we're going to continue on this time with a couple different topics. I'd like to go over what gave me a lot of motivation to even begin this show.
Really?
A couple winters ago, a couple seasons ago, I was watching some of the old film of Richard Feynman, his famous lectures, The Character of Physical Law.
Mr. Feynman was quite the fellow.
What we're going to be doing is The Character of Quantum Law. This is a further update to the physics from the old Wavemaster.
Very well, proceed.
This is a transmission from the new Wavemaster, or another Wavemaster, or the current Wavemaster. I will offer a H-wave container which will include all of the correspondence and information and mathematical numbers that everybody wants to look at.
The current Wavemaster.
So the entire presentation will be in the form of an H-wave container.
The current Wavemaster.
Which is essentially one side of an argument.
Wavemaster.
And or a proposition and or a statement. So it isn't necessarily to convince or not. It is simply to inform, with much else mixed in, because sometimes people think it's extremely professional, but a lot of the times it's jury-rigged. People just guess and get it right using inferences and other factors and variables.
How about more topics relating to time?
Carlo Rovelli's work on granular time.
Yes, equations that often exclude time variables.
And his brief on the order of time. And this is not a brief history of time.
Hey, no.
And this is also not brief answers to big questions.
Get back to the lesson.
Or anything of the like.
I gotta pull more jokes on you.
I am fond of this idea.
He could use the excitement, surely.
That's kind of funny. We're going to get further into this episode. I wouldn't say that it's necessarily starting easy. We've already had 30 episodes, and if you're up to date on those, you are likely able to continue on where we're at now. If you're able to get past your deficiencies and get it started right away. If you're behind, if you're not behind, it doesn't really matter. This is a good time to start with something that is putting some of these topics together in an orderly fashion in the presentation of the entire course as a whole. You could look at the entire podcast as an entire course, from start to finish, PhD. From start to finish, PhD. It's quite long, from start to finish, PhD. It involves a lot of stuff, and at some point you need to start going through the correspondence that we all have to go through, that we all had to go through in order to get your PhD in a top-level physics-related field.
There seems to be quite a lot these days.
Astronomy, physics, computational physics, materials physics, lasers and optics physics, professional physics. We've been over some of them. Now we're going to actually start going through coursework, and it's not going to be like blah blah test, blah blah quiz, blah blah formula. It's going to be blah blah blah. What it is.
LOL.
It's going to be a brief technical explanation of a subject, several at a time. A lot of these we don't need to spend an entire episode on. A brief technical explanation of a subject. In fact, this one is me telling you what types of classes and the general order and flow and of what the correspondence will be. So we're just getting to this one now. I'm not going to list off my proposed list for the next 10 episodes either, because I will likely change them before I actually finish producing them. This time around, we're getting back into specific subjects. Where do you usually start? A lot of people are going back to school, just starting school, getting school going, secondary and post-secondary, mostly post-secondary and beyond, starting there. We expect you to have a high school diploma or equivalency of some kind. These vary widely throughout the world. There's a general consensus what is to be included in those. You can start taking this class right out of high school and or in high school for credit if they allow that where you go. So this is the general class to get you going whether you have a deficiency or not. You may have a deficiency, you may not. These are often the other science classes that other majors in the college take as well. But people who are majoring in the main subject also take them to see where they're at because they may not be ready to go into calc-based physics, which is still not all that hard, but this one gives you almost all of the main ideas at the beginning of the correspondence course involving physics that you need. It doesn't use the math. It doesn't have as many formulas. You can get by with only understanding algebra. And for the most part, most people do. It just sucks, of course. It's all built off of the easier topic. We have to give an outlook of what subjects may be covered and what might not. It just sucks. We can go through a few here. You would start with that one. You need to get your math courses done. Calc 1, 2, 3. You need to go into your physicses 1, 2, 3 after the beginning class, or if you're up to speed right away. And you can do them concurrent with calculus. Sometimes they do them all at the same time, but they recommend doing one of calculus first, then one of physics at the same time as the second in calculus, and then the second physics at the same time as the third calculus, and then the third physics at the same time as DEF-EQ and higher math. So it's recommended to get through some of the math or at least be up to speed before you get deep into the calc-based physics, because they don't stop for calc, they just do it and teach you the physics. So there's a lot of shit in beginning physics. So the 3 semesters go over different things. You start out with Newtonian mechanics, boxes, levers, pulleys, projectiles. You do lots of other random small niche areas of mechanics, like things involving rotational inertia. Then you get into moments and other stuff.
Very tedious subject matter, even for undergraduates these days.
Then there is an entire arena that uses heating and cooling. Thermal physics at its core can be applied in many different areas, but one of the main ones we all think about is heating and air. Wherever you're from, whatever your weather may be, a good example would be taking note of your weather, because that is your outside reservoir if you are in manufacturing of some kind and you need some sort of exhaust for either vapor or air. Let's say we have a clean computer warehouse, so all you need to do is output heat in the form of breathable air that you just move from the inside of the building to the outside of the building. You need to know what your average weather is outside the building. There's a hot reservoir and a cold reservoir, so it just moves it from the cold to the hot. It moves heat from the cold to the hot, and then has a mechanism to generate colder air and keeps the cycle going. But they move on to electronic stuff. It's electricity and the fundamentals of our electronics and how they deal with other various forms of doing physics with electricity.
They get into what they can.
So once you get all those done, then you can actually go into the other stuff. Mechanics, quantum mechanics, We've already had some of that because it has been recommended to me to recommend to you to take brief courses in quantum mechanics earlier than later.
That sounds like something that Dr. Lee Smolin would say.
I honestly think it is worth doing earlier than later because across the board, there are many industries that take advantage of principles that include quantum mechanics. So if you have already a brief understanding of what it is, if you even know what it is and how it may apply to your industry, they are likely to hire you over somebody else. You'll get promoted quicker. You'll actually be able to do higher level work. So at some point, they're going to need somebody who can supervise the industry, and having an understanding of such things might give you the edge. Whether that's the only class you take or you specialize in it, it is worth taking at an earlier age than third, fourth year. Take it first, second year. There's also specializing courses in electrical and electronic circuits. There is further stuff with physics and astronomy where they cross over, so it is worth taking a seminar for that. You can go off into static material physics or astronomy, astrophysics, galactic astronomy. We're obviously going to want to move further into the more interesting topics that are not frequently discussed in mainstream courses. This isn't exactly a mainstream course, but it is the exhibition of real-world physics on set so that you can understand how it is done in the field. There are other things we can go into here, but let's keep it at a brief for that. At some point over the next 20 or 30 or 40 or 50 episodes, we are likely to get into some of these specific areas that I think are cool. So we may not have time to get into a lot of this stuff, but there are other areas that we're going to go deeper into. I want to know more about the possibilities of negative matter. I need to explain the math for the next type of satellite constellation that will help us mix Earth satellite positions with solar satellite positions. Hooking together multiple systems is very hard, and getting machines and satellite drones to be able to do that is the next area of space exploration for the next 20 years, at least. That is the outlook we are looking at. Hopefully I can get this entire thing done in under 20 years. We shall see. We will probably be seeing the complete degradation of Moore's Law here very soon. So Moore's Law no more, or what?
You should probably make it a point to do an episode on that concept as well.
It's whatever we want to make it. What do we want to make it? Are they going to figure out another way to make semiconductor electronics the same way they've been for the next 20 years or not? Or will they switch to a new system in the next 20 years? That is the question. We're not going to leave out the difficult physics for the next 20 years. We are going to still compare different methodologies which attempt to solve phenomena in the quantum with some sort of conformal theory which has been worked on by other physicists and wave masters. Some people are like, who is Richard Feynman? Well, he got more fame when he explained the reason why the Discovery space shuttle crashed in 1986. O-ring freezing temperature thing. Something to do with the physics of that. But you will hardly be able to understand that physics unless we go through this physics, this list of episodes.
Pardon me, good sir, Herr Einstein.
Yes, Sir Isaac Newton.
Don't you think he should take the time to go into audio engineering and podcasting in general? Do a podcast on podcasting, so to speak.
I'm sure he will.
We will get into some other niche areas like Maxwell's demon. We need to go into stuff about programming, stuff about the mind, stuff about other history, more things dealing with time. There are lots of other things dealing with string theory and loop quantum gravity we can get into. We can even just talk about orders of magnitude.
There are many subjects to cover.
We can get into the different types of string theories, brain worlds, maybe discuss some famous books that have come out in the last 20 years that were quite sensational, and others were good works of near nonfiction. A lot of them still have a tiny bit of fiction in them. We're talking about the books that are on on physics and math directly as well. So you need to take all of these writers' works, these publications, with a grain of salt. In fact, we need to go over different adages that we humans tend to make so that the artificial intelligences are able to quantify some of the mundane human frivolities that we experience.
Need I remind you of the time, midway?
So that we can get our thoughts and our wits back about us. But I digress. Grass. We need to take a quick break for now.
We're at the midpoint
Of episode 31, College Physics of Quantum Foam. You know, it is always nice to have a quick break halfway through because we get into these topics that range pretty far and few between. We'll probably go over topics that are not your normal topics, weird topics, hot button topics, things that are relevant for certain reasons on a global humanitarian level. Things like eugenics, the next physics paradigm, if they can crack this supergravity stuff and manipulate gravity on higher levels than Fermi-Dirac and Bose-Einstein statistics can offer us. It is very hard to do this because there are so few of us who understand such things. But you do have to start somewhere. The places and the things we have come up with. You do have to start somewhere. In other episodes, I somewhat briefly went over you do have to start somewhere. Some of the classes just based on my experience. We get into the different topics that they cover. The main thing is people wonder why they have to go over the same physics that they just went over in high school. Well, sometimes it is the same, but not all high schools teach their kids physics to a proficient enough level. Now, they do have accelerated physics and chemistry. Generally, those are at a high enough level. I definitely was in both at the same time, actually. But it doesn't necessarily mean you know physics better once you get to the collegiate level, because by then you're able to do it at a is it right or wrong level. You can use math to check your work, and it will tell you if you're right or wrong. So there's lots of other cool areas you can take towards the end of your degree, but
I think it's more important to make sure they know the main focus of the beginning of physics in college. The second half of your degree is the same material but at an undergraduate research level.
let's go over the main stuff involved with the three main doozies that you have to take. There's obviously the three main calc doozies also.
Just to make sure they know, I will briefly go over the calculus classes. They teach you how to solve derivatives and calculate integrals. There are special methods of doing each. Then they teach you certain integral number series which form the basis for more advanced calculations. Then they make sure you can manage dealing with 3 dimensions and above. This now gives you the foundations to solve differential equations of various kinds. That is a very short description of the calculus series.
Since that's math, that's separate. We're talking the physics doozies, the 3 main physics doozies. Now, you almost need to take a year and a half of physics at the second year level. So that means you should be taking some of that your freshman year probably. And if you're putting it off, then you're putting the entire program off. What we were getting at earlier, it might be better to be proficient at your math before you even take any of the physics. You could be 1 or 2 classes ahead. You could take all of them ahead. The fact is, that is what we were describing earlier as well. There's actually a class called college physics. But yes, we are talking about a degree, a college physics degree. They are separate, but that would be your descriptive physics or your something physics that's before your calc-based physics. So different colleges call them different things. That's some variation of what it is. We could go over some of the topics to give you an idea what is included in each of these classes. So the first one, yes, it's a review of some of the stuff you've done. Speed, displacement, velocity, uniform accelerated motion, Newton's laws, equilibrium, concurrent stuff, coplanar stuff. Then you get into work, energy, power, impulse, angular momentum, rigid rotation, springs, fluid, heat, gases. elasticity, thermodynamics, all in the first course, however much they cover in that term of those topics. The next one you can get into separate things. This one is actually more your electric fields and your capacitance and current, your electrical power, circuits of various kinds, magnetic fields, generators and motors, different things with lenses and optics, refraction, reflection, interference with optics. They can get into that stuff. And apparently the third one is where they cover things of atomic physics level, nuclear physics, atomic physics, subatomic physics, quantum physics. They touch upon that, and also special relativity. Do you have to take them? The Einstein stuff, some of the easier equations. It familiarizes you with wave mechanics in general, and how that can be somewhat combined with special relativity and quantum physics to make it separate sciences. That is all the stuff that they go over in those first 3 classes that should take you 1.5 to 2 years to finish. So there are different focuses that you can do that vary, so you can get different minors. You usually get an automatic minor in math if you just take possibly 1 extra class, 1 or 2 above the Calc series, so it ends up being a minor.
A good math class to take in order to get a minor in mathematics is linear algebra, matrix theory.
You could do different languages, Spanish, German, French, Chinese. You can do English, things with written composition or poetry or literature, composition of some kind. People specialize in that. History, psychology, sociology, people often get into other stuff with that as well. There are many other things you can do that vary. But if you want to fill your years with mostly math and physics stuff, there are some niche courses you can get into that are a little bit more fun than some of the standard ones like experimental 1, 2, 3. So it would actually be cool to be able to do atoms, nuclei, elementary particles, the experimental foundation for an understanding of atoms, nuclei, and elementary particles in general, focusing all on that. You can do undergraduate work. You could do an undergraduate thesis. I never wanted to mess with that because I figured I would use my thesis for my thesis. So this is the thesis. It is anti-theatrical. It is the antithesis of your thesis. So you might as well wait until you get your professional degree to do that.
What exactly was your thesis about?
You can get into optics, lasers, lots of different things, but more than likely you're not going to have
Optics.
enough time, lasers, to get too specialized into some of these areas.
Optics.
Which is why lasers are niching out the astronomy. The thing is, they obviously always need more astronomers and astrophysicists. So by all means, take the subject if you can handle it. If you want to do something profound and always be needed and always have work and always be able to solve problems and help people, then this definitely would be an occupation that you can do almost anything with. Anything from the ground up you can do. The possibilities literally are endless. What skills can you transfer? Taking courses like this would help you make predictions using mathematical, statistical, and scientific modeling methods. You'd be able to present research to groups of all sizes. This is going to allow you to solve real-world problems for companies across the board. You'll be the guy who explains the data. And when people are like, what does this mean? You have to explain until they finally understand what it means. You'll be the guy who explains the data. So, being able to compose convincing arguments and presenting logical information for people to make informed decisions based upon. This is being able to evaluate complex information on the fly. What causes what? What is the reason that this happened? Why does this happen? How do we fix this? These are the people who are going to have to design the experiments for others to run even, once you get pretty deep into it. You need to be able to be inquisitive enough when you're critically reviewing the scientific information to make informed decisions. You will have to know what the proper practices are. Laboratory safety.
Laboratory safety.
All of that.
Yes.
Standards, codes, the use of many different types of instruments. Technical skills will be required. A lot of these people are doing software of various kinds, teaching mid-level and high-level technicians, and this is only with the 4-year degree. So people who are getting the higher level stuff,
They usually run some research somewhere and assist.
you know about what it takes to get a 4-year degree at any college that's related to math or engineering. It usually has higher standards of tests to get into the college straight up. They test you to make sure that you're ready to do it right off the bat. Depending on how far ahead you are, you can get into other specific classes. If you are far enough ahead and you just want to take cool classes, just take descriptive astronomy or descriptive physics, whatever they call it. It would be one that only uses algebra or trigonometry. So almost anybody can do it, especially if you're going to be going into a science or math-based program of study anyway. You should be able to handle this with no problem. And you will likely have the mathematics prerequisites already. So if you're able to actually get into some of the cooler classes, you can do things like physics of the interstellar medium. That stuff's pretty sweet. Actual stellar astrophysics, the physics of stars and how they work, how the big ones work, how the little ones work, where they're all at, why they're there, what they're doing, what it means. You can get into extragalactic astronomy, which just sounds cool. We're talking about galaxy formation and big scale stuff. And it's pretty exciting because I believe they're going to be able to see a lot more here coming up, but we are all waiting on that James Webb Space Telescope. There should be no issue with the name of it. It's just a damn name. Who cares? We're all going to like the data from it, so who cares what the damn thing's called?
James Webb was apparently racist.
So they need to get it up there before too long because we need that updated data. So depending on how your program of study goes, you're going to be filling it with lots of other classes that have nothing to do with the general subjects that we're studying here. But essentially this could give you a primer for what you're likely to expect going into any program at any of the major colleges around the nation or world, because it's all the same stuff.
It is equivalent.
We need that updated data.
There are different accepted symbologies and forms of notation that different schools of thought follow. They all communicate however they need to with what they're talking about. We should have a good understanding of what is expected with this. There's a lot of different things we can go into, but we're going to take it easy starting off this decimal. We're going to get into more difficult stuff later on. We are going to keep having fun with the characters that we have already introduced.
Yes.
Because there is plenty of epic storytelling to be done. It's pretty cool that things like Rick and Morty get orders ahead of another 7 seasons or whatever, and that's pretty badass. I'm ordering the exact same for my shit. Another 70 on the motherfucking platter. So let's see how long it takes to get this shit going. I'm ordering the exact same for my shit. I'm going to just focus on getting the next 10 or 20 first. Maybe get 50 down and be like, aight. So let's see how long it takes to get this shit going. For now, we have to keep moving forward. There are many other topics that I want to get into, and a lot of people may not necessarily care too much about this college stuff because you may just want to do something with this that isn't going to require you to do a degree. You may not ever have to do the degree, and it may not matter. This is the ins and outs of the degree for somebody who would do it. So at least it is giving somebody a primer on what's included in this subject without actually having to take the class to know what the hell it is and waste their time. If a lot of this stuff is something you're not going to ever want to do, then you may never want to do anything related to these subjects. You need to find that out, and it's a lot easier to just listen to a nice, descriptive, accurate show with ridiculous shit in it in order to find out your info, because the info has been went through. So we're not worried about that. It's like,
What the heck is that thing?
it's a pad buff. It's for calligraphy, man.
Paper.
It doesn't have to be for calligraphy.
It's for whatever you want.
It's for steganography. An NFT is just steganography on digital shit. But at some point we will explain that to these different people. I keep giving random examples about the cryptocurrency because I am actually doing the physics that I'm speaking about. So at some point I will go over the thermal physics and the designs that I have implemented after an actual creation and the tests and the numbers. So I'm sure I will need to explain that, and that will be another way I did it, but that's what I've been doing the last week. There are lots of things that need to be done that require attention. Editing and producing is definitely one of them. So another website, another couple hours of audio, another software stack, more equipment, more machines, more income, more things to build, more problems to fix. At some point, we will get back on the grind. Right now, we are able to do a little bit.
Keep making progress.
For sure.
Indeed.
For now, that is it for episode 31, College Physics of Quantum Foam.
The zeroth wave disclaimer.
The views and opinions expressed in this podcast are those of the author or authors and do not necessarily reflect the particular views, thoughts, or opinions of Zeroth Wave Productions, any of its sister companies, its parent company, Zeroth Enterprises, or any other entity which had existed, will exist, or which, quote-unquote, presently must exist outside the realm of our current space-time.
Quantum Foam is produced by Zeroth Wave Productions.